we're taking a look at problem 206, reversing a linked list. I'll definitely be adding a link to this problem down in the description below. So what they're asking us to do is basically to flip our linked list. So what was once our head is now going to become the tail, and what was the tail is going to become our head. So I'm going to show you guys the most efficient way to do this. And I mean, as always, the best way to get better at these type of problems is to practice. So I really would recommend, while I'm explaining, just stop and code along. Once you feel like it has made sense, I would say delete everything you've written down and then start again, right? Because you really do want to understand the basics so that when it comes to the more complicated problems, you already have like a really good foundation. Reverse this singly linked list, we're going to initialize 2 pointers, right? So we're going to have our current pointer, which is going to point to our head, and then we're going to have a previous pointer, which we're going to use to keep track of our previous nodes. Because remember, in your linked list, your singly linked list, when we move to the next node, so when we go head dot next, we lose reference to the previous node. So we have to make sure that even though the current pointer has lost reference to us, we have to make sure that we're keeping this in memory. And so this is why we use the previous node. And also we initialize our previous pointer, this one here, to none, because remember, at the end of our list, what do we have? We have none. So technically, we're not going 5, 4, 3, 2, 1. It actually starts at none, then it goes to 5, then 4, then 3, 2, 1, right? So this is how we're going to reverse that. And so how do we reverse it, right? I think that's the most important thing. How do we make sure that this arrow is no longer pointing to 2? Actually, let's put it back at the head, right? So if we initialize it at the head, which is 1, how do we then take this arrow and point it, right? So it's not pointing to 2 anymore. We don't want that connection. How do we take this arrow and reverse it so that it's pointing to here? Well, the way we do that is we go current.next, right? Because current.next is pointing to 2. Instead of making it point to 2, it's going to point to none. Let me just move this here so you can see it. So we simply go current.next is pointing to previous. So now it's 1, none. But the problem we have, right, the moment, remember, when we go current.next, we lose, right? We lose this arrow here. We don't have that anymore, which is a problem because it means we don't have access to the rest of our list. And so this is why we're actually going to initialize, we're going to have another temporary pointer. And this is why you can see in blue I wrote temp, because we need another temporary pointer that is going to be pointing here, right? Which is basically what? Temp, which is current.next, right? So it's pointing here. How do we get access to this? Well, we simply go current.next. It gives us this. Okay, so I'm going to put back the original arrow just so you guys, we can start from the beginning and go through the logic. Okay, let me just duplicate that. Okay, so now we have 3 pointers and we're going to take it from the top. The first pointer, which is our current pointer, is pointing to our head, right? It's pointing here. We have our previous pointer, which is pointing to none. Then we have this temporary pointer, which is pointing to current.next and putting it here. So what happens now? So when we flip it, right? The way we flip it is we go, okay, instead of current.next being equal to, not being equal, sorry, but pointing here, we want to flip it around so that current.next is now pointing here, right? Want to point it to this none. And this is the logic that we're going to use. Current.next is equal to previous. So even though we've lost connection to the rest of our list, because we have this temporary, we have this temp here, we actually don't lose the connection anymore because we're saving it with temp. And then what we do from here is we go, okay, so this current is now 1 and none. This is still none. Then we go, okay, previous, I want you now to come here, right? So we go, this arrow moves down here. And now that you are here, we go, okay, you come here. And we go, okay, now that current is equal to here, and the way we do that is we go, okay, now current is equal to temp, putting it back here. And we go, okay, now you can move to the next one. So we just go current dot next, it moves here. And we basically keep repeating the same logic where we go, okay, now that everyone is back in their individual places, let's do it again. So how do we flip this arrow? The exact same thing. Okay, let me just move this because it's distracting. The exact same thing, we want to flip it. So we're going to go, okay, current dot next is equal to previous. Because remember, where is previous now, right? Previous is pointing here, right? And we go, okay, flip it. I want you to point here. Fantastic. We go, okay, now that current is pointing here, previous, I want you to come and be in the same spot. So current, I want you now to equal to current. And then we go, okay, now that previous is here, current, you can move to the next one. And the reason why current can move to the next node in our original list is because of temp. And we go, okay, current, now that you're here, temp, you can move, right? And it's literally just us. We're going to keep doing the same thing, right? We go, okay, now that current, you are here. Everyone, so every single time, in your head, just imagine the arrows. Each time the arrow is in its individual spot, we do the flip. We go, okay, let's flip it again. So current dot next is equal to previous. So you are pointing here. We go, great, we flipped it. That means previous can move to where current is. And we go, okay, current, you can move here. And we go, now that current is here, temporary, you can go to the next one. And then again, each pointer is in its individual, it's pointing to it, like all of them are pointing to their individual nodes. And then we go, okay, so let's flip it again, right? And you go, okay, current dot next, let's flip. We do the flip again. Right, we go, okay, now you are here. Then we go, we've done the flip. Previous, you can move. I have moved. Okay, current, you can go to the next one. Thank you very much. I'm going to the next one. And then this goes here. And again, everyone is in the individual spots. And we go, okay, let's flip it one more time. And then same thing. We go, okay, let's flip it. So this here is gone. You're now pointing to the next node. Has it been flipped? Yes, it's been flipped. Okay, previous, you can move to the next one. Okay, current, you can move. And basically, we are done flipping, right? Because this is what we were expecting. Back at Leetcode, the actual logic itself, honestly, is really short. Once you understand the pattern of moving our pointers, it actually makes perfect sense. So if you guys remember, we did have a current pointer and then we had a previous pointer, right? And current was initialized to the head. So in this case, number 1, if you look at the first example, and then previous, we initialized to none. And we're going to be using a while loop because if you remember, and you can go back, once current reached none, it meant that our list was flipped. So we're going to say, look, while current, we want to initialize our temporary, right? Because temporary, every time we flip, we lose access to the rest of the list, and temporary makes sure that we're not losing access. We're not losing reference to our list. So we'll go, look, temporary is just equal to current.next. And then now we're going to do the flip, right? So when we flip it, we go, look, current.next. I don't want it pointing to 2, but I want it to point to previous, which currently is none. Right, so once we do the flip, what do? Then we move our previous pointer. Okay, previous is now equal to current, right? And once we move that, we can go, okay, current, you can now go to the where temporary is. And it's just that repetition, right? And then once we exit our while loop, we know that we have flipped our list. And I mean, that's basically it. I really would encourage you, if it doesn't make sense, play around with those pointers. tear pieces of paper and write down like the arrows and the numbers and keep moving things around. Use your fingers. The more you sort of practice the pattern in your head, the easier it is to understand the code. Okay, as always, good luck.